right. So let's go ahead and move on. We're going to go ahead and solve for quadratic equations. We're going to go ahead and use our beautiful factoring method, and we're going to be given trinomials, basically beautiful equations with 3 terms, and our leading coefficient is going to equal to 1. So this is our beautiful first method or second method. We just went through square root method. We're moving on to the next method of solving quadratic equations. We're going to use factoring. So we've learned how to factor. Next step is now how to solve them when they're given in an equation form. So if you guys remember, sorry guys, I don't know if you had this already done, written on your beautiful paper. Okay, perfect. So if you guys remember, we had quadratic equations. Our highest degree is 2. So it means that we're going to have at the most 2 solutions. We're going to make our beautiful y equal to 0. So our beautiful right side is now going to be equal to 0. Okay. So I showed you guys many different ways of how those graphs look and where they're being interpreted. And now we're going to go ahead and move on to our first example. So go ahead and copy this one down, guys. K plus 1 and k minus 5 equals 0. Now, how do we know if it's a quadratic equation? Well, if I were to go back and distribute all our beautiful values, multiply and distribute and combine like terms, our highest degree would be of 2. Now, notice here that they're already factored for us. So all we have to do is think about what would make our beautiful solution equal to 0. What would be the values of k? Now, since we already have one factored given to us as k plus 1, the second factor of k minus 5, we need to think which one of these is going to be equal to 0. Now, the reason being is that if this beautiful factor is equal to 0 and I multiply it by k minus 5, what would be the value? 0, because 0 times anything will make it equal to 0. Now, the same idea happens whenever we have the other factor equal to 0. So let's say that I have this one equal to 0, and I multiply it by k plus 1. What's going to happen? It's going to be equal to beautiful 0. So our question is, what value of k makes this factor equal to 0 and this factor equal to 0? Well, this is how we're going to go ahead and solve it. We're going to go ahead and grab one of the factors, k plus 1. We're going to make it equal to 0 to find out what value makes that equal to 0. And we're going to grab the second factor, k minus 5 equal to 0, to know what factor or what k value makes that factor equal to 0. So, one-step equation, guys. I take you back to algebra 1. How do I solve? Minus 1, k equals -1. On my other beautiful factor, plus 5, k equals beautiful 5. So in this case, how we did our square root method, we had a plus and minus and then a value. This time we're going to have, we might have the same one, we might have the different values, but this time k has to equal -1 and +5. My solutions might be different, majority of the time will be different from each other. They're not going to be plus and minus a particular value. This time we're going to have 2 different solutions. So this is the values of beautiful k. Not too bad, right? Okay. All right. Let me go ahead and save. Clear. Go ahead and try this one. Let's see if you guys got this. A plus 1 and a plus 2 equals 0. Ozzy. Yeah, you are here. All right. Share with your neighbors, check in with each other. Let's see what you guys got. Check in, guys. Check in. Our signs matter, guys. So we want to make sure we have the correct signs. The signs matter. So we're going to make one factor equal to 0. So a plus 1 equals 0. And the second factor? A plus 2 equals 0. They happen to be one-step equations right now. So let's see. How do I solve my one step? So A equals -1 and -2. So A is -2. So what are my two solutions? And -2. These signs matter, guys. Please pay attention to your beautiful signs, okay? All right, let's go ahead and step it up. This is example number 3. Now, what happens when they're not factored for you? Well, when they're not factored, then we have to factor. So let's go ahead and imagine that we don't have that equals 0 on the beautiful right side. Just for an instance, how do we factor that beautiful trinomial? Power Ranger method. Okay, so let's go ahead and apply it very quickly. Woo. Two numbers that add up to and multiply. 6 and they add up to beautiful 5. What are those two values? 2 and beautiful 3. So I'm going to write my beautiful factors. X plus 2 and x plus beautiful 3. Let me clear my 0. I happen to have a beautiful right side equal to 0. So what do I do with the two factors? Make them equal to 0. So my first factor is x plus 2 equals 0. And the second factor, x plus 3 equals 0. One-step equation. Subtract, 3. Subtract 3, x equals -2 and -3. And you can go back and substitute your values and check to see if indeed you're going to get 0 for those solutions. You should have them as equal to 0. So we can go back into our beautiful equation. 2 -2 squared plus 5 -2 plus 6, and we should have it equal to 0 and check and see if the other solution will also be 0. Okay, all right. Let's see if you guys got this. Go ahead and factor x squared plus 2x minus 63 equals 0. So again, my first step is to factor, then set our beautiful factors, each factor equal to 0. This is example number 4. X squared plus 2x minus 63 equals 0. I'll give you guys about 10 more seconds. All right, share with your neighbors, guys. Check in with each other. A ver. Let me see who's going to be my volunteer for this one. So, listo. So we're going to go and do the Power Ranger method. Power Ranger thingy. ¿Qué es eso? A ver. Okay, so what goes on top? -63 and below. 2. What are my factors? 9, -7. How do I write my beautiful factors here? X plus 9 and then x minus, there you go, 7. All right, now they're equal to 0, so that means that one factor has to equal to 0, so therefore x plus 9 equals 0. The second factor has to also equal to 0. 0. What's my solution? Subtract 9. And over here we add 7. So therefore my solutions are -9 and +7. Be very careful, guys, with your beautiful solutions. Don't get them confused with your positive and your negatives, and your negatives with your positives. Again, that's something that I emphasize a lot. Okay. All right, we're not done. What happens when my right side is not equal to 0. What do we do then? Well, we have this case right here, x squared minus 11x plus 19 equals -5. So something that I like to do in algebra is manipulate our beautiful terms so that it looks the way that we are used to seeing our beautiful equations, right? So in this case, we're used to seeing our beautiful right side equal to 0. Well, it is not 0, it is -5. However, we can manipulate our equation so that it does look to 0. So how do I make it look to 0? I can go ahead and do the inverse and add it to the opposite side. Now, make sure that whenever you're adding it to the proper term. So for example, this is a constant. It has to be combined with a constant. So we have here x squared minus 11x. Now we have 19 plus 5 is 24 equals beautiful 0. Now we can factor. So two numbers that multiply to positive 24 and add up to -11. -8 and negative beautiful 3. So here are my beautiful factors. X minus 8, x minus 3 equals 0. We make both equations -8 and x minus 3 equal to 0. Add 8, add 8. Add 3, add 3. And again, some of you guys are going to already identify your beautiful shortcuts, whatever you guys need to do. But make sure you guys check your beautiful work. What are my solutions? +8 and +3, or +3 and +8. The order in which the x solutions are given does not matter. You still have the solutions present there. Okay. All right. Let's see if you guys got this. Before I give you guys a practice assessment here. Assignment. Go ahead and try this one. Let's see if you guys got this. 6n to the power of 2 minus 18n minus 18 equals 6. And actually, we haven't done this one yet. So let me go ahead and walk you guys through this one. So the same idea, we need to make that right side equal to 0. So how do we make that right side equal to 0? Subtract. So this time we have to subtract 6. Now, make sure that you subtract it to the appropriate or the like term. The like term happens to be another constant. So 18 and 6, or -18, -6 have to combine together. So we have 6n to the power of 2 minus 18n. -18 minus 6. -24 equals 0. Now, my leading coefficient here happens to be what? 6, right? We have a beautiful 6 here. Every time that we have a coefficient, we always check if it's a GCF. So is it a GCF? Yes, it is. Let's go ahead and factor it out. 6. Inside my beautiful parentheses is n squared minus 3n. And minus, we take out the 6, so we're left with 4 equals 0. So all we did was factor the 6. Okay, step by step. Now, if we were to make our beautiful polynomial here inside n squared minus 3n minus 4 equal to 0, and we multiply it to 6, what would be the solution? It would be what? It would be 0, right? So are we interested in this beautiful 6 now? Well, whenever you factor, you try to find the factors, then yes. But now we can go ahead and divide both sides by 6. So that takes care of that beautiful value. We're left with n squared minus 3n minus 4 equal to 0. Now we're used to seeing it how we've been seeing it, and we can go ahead and do the Power Ranger method or any type of factoring method that you guys know and factor. So two numbers that multiply to -4 and add up to -3. We have -4 and beautiful 1. So n minus 4 is my first factor. N plus 1 is my second factor equal to 0. Let me go ahead and move it up here since I'm running out of space. N minus 4 equals 0 and n plus 1 equals 0. Be very careful when you do your beautiful inverse operations. Plus 4 minus 1 minus 1. We're left with n equals +4 and -1. Woo-hoo! Les dije, I told you guys it wasn't too bad. You do the same procedure. And you combine like terms, yes. So we are used to seeing our beautiful right side equal to 0, but this time we don't have one term, but we have two terms on the beautiful right side. How do we manipulate our equation so that our right side is equal to 0? We're going to do the opposite of the inverse operation. So we are going to add 30, and what? And subtract 11, or make sure you guys apply it to the corresponding term, the like terms with the like terms. See, no, everything's gonna go. Okay, all right. 5r squared, 44 minus 11, -44 minus 11, -55r, 120 plus 30, 150 equals 0. $15.30. All right, we have a GCF. What's our GCF? 5, take it out. R squared minus, we took out the GCF of 5, 11R, we took out the GCF of 5, and it's beautiful +30 equals 0. What do we do with this beautiful 5? Divide both sides. Get rid of it. We don't need it right now. When we're factoring, yes, but right now, since we're solving, remove it. We don't need it. So we're left with R squared minus 11R plus 30 equals 0. Two numbers that multiply each other and add up to 30 and add up to -11. Sorry, multiply to 30 and add up to x and 5, negative. So therefore we have R minus 6, R minus 5 equals 0. R minus 6 equals 0 and R minus 5 equals 0. Inverse operations, add. Bless you. We're left with R equals +6 and +5. Woo-hoo! How do we feel? Okay, so I told you guys, factoring is essential here. Okay, all right, I'm gonna go ahead and let you guys practice. Let me go ahead and give you guys your beautiful quizzes. Mother, go ahead.